Let's go through the code 794, valid Tic-Tac-Toe state. And for this question, it has a board. This is a 3 multiple by 3 board, but actually we can do some kind of generic situation that to be n multiple by n, right? Because we have another question, will be do this a little later. That is the n rows and n columns. So let's do this kind of things more generic to be inter n equals board dot length. And it let us to validate with this kind of Tic-Tac-Toe state is some kind of valid state. Okay, so we know for this kind of game, that is if the in any row, for example, x has been formed one line, then x wins, right? Or in any column, it forms one line, then x wins. Or in any diagonal, right? So if we have x, we use some different color. X here, then x wins as well. So the same thing with O, right? So if there is O here, it forms a diagonal for a line, then O wins. We know for this kind of question is that if any of x or O win, right? Then the game finish. So it is not possible in this kind of board we have both x wins and O wins, right? X win and O win. That will return false. It's possible because any one of this kind of wins, then the game will finish. So we cannot have a scenario both x and O wins. So this will return false. And the second thing is that if x wins, right? X is the first person to play. Then the game wins. Then we'll say x has placed one more steps than O. So we'll have should return x count equals O count. How many x in the board? +1, right? And the third scenario is O wins. Then we'll have O count equals x count equals to O count. And then the fourth scenario is that none of x and O wins. Right? That is, they are still tied, right? Then we'll just count how many x in the board, how many O's in the board. We'll just have x count equals O count, or x count equals O count +1. Right? So just we decide in this kind of 4 scenario. Both x and O wins return false. And if x wins, we should return x counts equals to O counts +1. If O wins, we'll return x counts equals to O counts. And none of x, the fourth scenario is that none of x and O wins. We just return x count equals O count, or x count equals O count +1. So this is what we think about. And also how when we count the x and O, right? We every time we count, we iterate the board from every row, right? I from 0 to n minus so on, and also the j from 0 to n minus 1, right? So every time we iterate I and j, what we need is that we can have an int array called rows. rows, right? So assume this is X, right? So we just have this rows plus plus added it to the rows I plus equal to 1, right? For X plus equal to 1. And if there is this row I equals to N, that means X wins. And for O, we can use -1, right? -1. So if rows I equals -N, that means for this step, O already wins. We need to check row I and column J, right? Because every step will affect rows I, column J, and also the diagonal, right? Diagonal, we can have two parameters, dg1, dg2. We can also use array, right? Because we want to have an have function. We can have int array dg equals new int 2, right? And let the dg0 to be dg1, dg1 to be dg2, okay? Diagonal, right? So we every time we place we count a chart, right? So we need to check whether for this chart whether it's possible that the X wins or O wins. So we can write have function for that. So let's begin to write code for this. And for X, we can use a flag, for example, +1. And O, we can use flag like -1, right? So what we need is that we have a rows array equals new int in and int columns equals new int n, and we have a diagonal array equals if you find right new int 2, right? And we are going to have int x count equals 0, o count equals 0, right? And we have boolean x win equals false, o win equals false, right? And we'll say for int I equals 0. This is row, right? I smaller than n, I plus plus. And we have for each row, it is a string. We need to we converted this to char array. Okay, array equals board I to char array. Okay. Then we'll do this for int j equals 0. For the column, right, is smaller than n, j plus plus. So let's say if for this array j, right, array j equals x, then we'll do something, right? Here, one of the mistakes someone is just put else to then calculate the O operation. This is not correct because in the board, the character can be X, O, or empty, right? So we'll write if array J equals O, right? Or something. What we need to do is that we need to calculate X or number, right? X count number. And we'll calculate the O count number, right? And we need to, for each step, we write a help function. For this help function, it will update this kind of row I, rows in the I to calculate the related X or O, right? And also column J, right? And if it is in the diagonal, right, we'll also update that. DG0 and DG1. And for each step, we can, in the meanwhile, trying to see whether this kind of step has get X or O wins. So we can use a Boolean calculate. And we'll have, so if this step, for example, if it is X, right? If for example, the row I equals N, that means it will return true. And if column J return equals N, or DG0, DG1 equal to N, then X return true, right? In the meanwhile, if this is O, right, we can use a flag like a -1. If it equals minus N, then that O wins. So we are going to have rows into columns. Let's put the diagonal here, DG into row, right, in column. And we can pass the N here, right? Because we need to compare whether it equals to N or not. And for X, we are going to have, because X and O, we want to have different values. We can just have value, right? In the value as a flag, right? So for X, we pass 1. O, we pass -1, right? So what we have is rows, row plus equal to value, okay? Columns, column plus equal to value, okay? And I will say if row equals to column, that means it is in this kind of diagonal, right? When we are add to DG0 the value. So DG 0 plus equal to value. Okay. And we'll say if this row plus column equals N -1, we'll have DG1 plus equal to value. Okay. We know this N that means if it is X, right? Any of this row, column, or this diagonal, these two values, if any of that equals to N, right? Then we are return true. And if it is O, right, this we're passing minus X. So let's say any of this value equals -N. So what about we have an int target? Int win number, okay, win number equals N multiplied by value, okay. So return rows row equals win number or column equals, because it will only affect when we add this one, only affect this row or this column, right? Win number or DG0 equals win number or DG1 equals win number. Okay. So every step we just in the meanwhile trying to see whether this kind of it has a win result or not. Here, the thing is that we should write if, for example, calculate rows, columns, BG, I, J, N, right? So if this one pass on 1, right? If we calculate, if this one have 1 step, this one is win, then we'll have x win equals true, right? Another mistake is that someone just write x win equals this. This is not correct because for one of the step, it may get this one win, but the next step, this kind of condition does not meet, then this one return false again. So we'll say as long as x wins, this one will return true. So we can put something like this, right? Or and so that means any of this one return true, this one will return true. Okay. So this is the same as if this one equals win, then x will be win. So we'll also have O win or and calculate rows, columns, e.g. I, j, and now we are passing a -1 here. Okay? So this will be our for every our function to calculate counts and also try to see whether there is x win or win, right? So as we mentioned, if x win and O win, this return false, right? False. And if because we cannot have a both win, and if only x win, right? That means return x count equals O count plus 1, right? X wins will terminate. X will have one more step. Then O place, right? If O win, we have return x count equals O count. The last case is that they are tied. If they are tied, also we'll have x count equal to O count or x count equals O count plus 1, right? So this will be calculate, cannot find symbol, rows, right? Should be rows 19, columns. This will be lowercase. 32, this will also be lowercase. Okay. Let's try to see this one. This one. Okay. The time complexity will be O n squared, right? So, but the space will be O n, right? Because we just use 2 arrays, right? Or I say this is also n. This is like a 2-dimensional array. This is 2 n dimensional array.